Okay, let's dive right into this. Welcome to today's Explainer. You and I are going on a really fascinating journey into the world of avian survival. We're going to start by looking at the sweeping global diversity of bird adaptations. You know, how different species have conquered just about every extreme environment on Earth. But we aren't going to stop at that macro level. We're actually going to funnel all that grand context down into an incredibly intimate scientific case study of one truly remarkable local species.
From the smallest hummingbird, they have mastered the skies. Now that idea that birds have mastered the skies, it is absolutely undeniable. But as we know, it's not just the air they command. Birds are found in the oceans, the driest deserts, dense forests, and even our most bustling cities. Every single call, every beat of their wings tells this compelling story of survival. And to survive, well, you have to adapt. Nature demands innovation, and birds are quite literally absolute masters of it.
80. Think about that for a second. 80. That is how many times a hummingbird can beat its wings in a single second. It's wild. Their unique wing structure lets them rotate in this figure-8 motion so they can hover, fly backward, and get this, even upside down. But that extreme physical capability comes at a really steep cost. I mean, they have to feed every few minutes just to fuel that high-energy lifestyle. It's a perfect example of just how hyper-specialized avian bodies have actually become.
Section 1. Masters of Adaptation.
To really understand this extreme spectrum, look no further than the puffin. Built for life on the wing, it truly excels beneath the waves. Using their wings almost like flippers, they can dive an astonishing 60 meters deep and hold their breath for up to a full minute just to catch sand eels. Now contrast that aquatic mastery with the secretary bird out in the African savanna. Unlike most birds of prey, this guy hunts entirely on foot. It covers these vast distances and uses swift, super powerful kicks to deliver lethal blows to snakes and small mammals. Same class of animal, entirely different biological machinery. And we see this incredible divergence even within the exact same family of birds. Take the emperor penguin. It endures months of freezing Antarctic winds. I mean, the male literally balances a single egg on his feet for over 2 months without eating. No way, right? Now compare that to the endangered African penguin. They thrive on the warm, sun-drenched rocky shores of southern Africa. They're smaller, much more agile, and have adapted to a completely different climate, though they do face completely different modern threats today, like overfishing and habitat destruction.
So, what does this all really mean? Well, the crucial point here is that while these global extremes are completely mind-blowing, the actual mechanics of survival and adaptation are ultimately played out on a micro level, in very specific local ecosystems. So we're going to shift our narrative focus right now. Let's move away from the ice caps and savannas and zoom right into the quiet, wooded areas of North 24 Parganas in West Bengal, India.
Which brings us to Section 2, the Asian paradise flycatcher.
This bird is absolutely famous for its striking appearance. It has 2 distinct color variations, or morphs, for the males. There's this rufous chestnut color and a stunning white plumage. But the most extraordinary feature, hands down, is undoubtedly those central tail feathers. In adult males, these feathers grow into these massive streamers that can reach up to 30 centimeters in length. To put that in perspective, that's about the length of a standard school ruler trailing behind this little bird.
Now, this dramatic visual difference introduces a concept called sexual dimorphism. Basically, this just means the males and females of the exact same species look significantly different. So while the adult males develop these massive 30-centimeter tail streamers, the females remain rufous with much shorter tails. Now, growing and flying with these massive feathers requires immense energy, and actually, it makes escaping predators a whole lot harder. But they are a vital declaration of vitality to attract females. It's this incredibly delicate balance, survival weighed directly against the harsh demands of reproduction. Beyond the tail, they sport these incredible bright cobalt blue eyelids and a metallic blue-black head that just shimmers in the forest light. And their vocalization is super distinct. Casual listeners might just hear a loud trill, but when researchers look at the audio waveforms, it reveals it's actually a rapid, continual series of 24 to 26 notes structured perfectly in pairs. It sounds like a rapid pi-pa, and the whole shebang lasts barely 2 seconds.
Section 3. Architecture and parental care. Their architectural ingenuity is genuinely staggering. The study documented their small, deep cup-shaped nests built primarily at the very ends of short branches in shady areas. They weaved this structure from plant fibers, twigs, spider silk, and lichen. But here is the vital engineering detail the researchers found. Every single nest they observed had at least one small branch running straight through the nest walls.
They literally build the nest entirely around a living branch to anchor it. It gives the home massive structural strength against wind and severe storms.
Once that nest is built, the female lays 3 to 4 eggs, and from that exact moment on, parenthood is a shared, relentless endeavor. Both the male and the female take turns incubating the eggs for about 15 to 18 days. Once hatched, they both constantly hunt for insects to feed the ever-hungry chicks. And it doesn't even stop at feeding. During rainstorms, the parents will sit right on the edge of the nest and actually spread their wings together, creating a living umbrella to shield their vulnerable chicks from the elements.
Moving on to Section 4, the rhythm of survival.
Now, the researchers tracked the birds' bathing habits and found a meticulously shifting schedule directly tied to the chicks' development. When the eggs first hatch, the parents bathe right around noon, but as the chicks grow and demand a lot more food and attention, that schedule shifts. After 5 to 6 days, bathing moves back to 2 or 3 p.m. By days 14 and 15, the parents are delaying their own bathing until 4 or 5 p.m. Every single hour of their day is dynamically recalibrated to prioritize the survival of their young.
And when they finally do get a chance to bathe, it is a highly regimented ritual. First off, they never bathe together. One parent stays back to fiercely guard the nest while the other flies to a nearby water body. The bathing bird executes this super precise sequence: a shallow dive into the water, a return to a branch to shake off the water, and then a repeat. It's exactly 3 consecutive dives, and then boom, they immediately return to the nest to relieve their mate. No lingering allowed.
To make sense of these highly specific actions, scientists use something called an ethogram. Basically, this is how researchers categorize and codify wild survival movements. They break down the flycatcher's day into classes like locomotive behaviors, hopping and flying, body care like preening and thermoregulation where they pant to release heat, and of course, consumption. By mapping these behaviors, we actually move from just passively watching nature to actively decoding the strict logic of wild survival.
Which brings us to a final thought for you to take away from this explainer today. From the 60-meter dives of the puffin, to the emperor penguin's completely wild Antarctic endurance, right down to the Asian paradise flycatcher perfectly timing its 3-dive bath to match the growth of its chicks, birds have survived by becoming intensely specialized. But these are very rigid routines tied to very specific environments. So in a rapidly changing world, with shifting climates and disappearing habitats, how will these highly specialized, delicately balanced survival routines actually fare? It's a huge question that researchers are racing to answer right now, and one we should all absolutely be thinking about. Thanks so much for joining me on this deep dive.